Hello, welcome back. In this calculus video, I'm going to be going over a very common type of related rates problem known as the ladder problem. Without wasting any time, let's get into it. So the question says a 13-foot ladder is leaning against a wall. The bottom of the ladder slides away from the wall at a rate of 5 feet per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 5 feet from the wall? Okay, so first, let's define our variables, and I've actually already done that here. So let's call x the distance from the wall to the bottom of the ladder, and let's call y the height of the top of the ladder on the wall. So this is y and this is x. So now, first, before I get into this, I recommend watching my previous video on where I went over the spherical ball, which was about we were finding the change in radius with respect to time, and that was my last video. I recommend checking that out so this video makes more sense and you understand my steps more. Going back to this problem, let's see what first the question is asking. The question is asking how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 5 feet from the wall. So what that immediately indicates to me is it's asking for basically how fast is y changing, right? Because it says how fast is the top of the ladder sliding down. So that means it's asking how fast y is changing as time passes on. So that means we're going to be figuring out what dy dt is in this problem. So now we're given that the bottom of the ladder is 5 feet from the wall. So we know x is 5 feet. If we know x is 5 feet, let me draw a right triangle to make this more easier to see. Okay. So we're given that this is 13 feet in the image of the ladder. And x, it says it in the problem, it's 5 feet, right? And that's what we defined x as, the distance from the wall to the bottom of the ladder. Using the Pythagorean theorem, we can figure out what y is. So that the formula is x squared plus y squared equals c squared. C is our hypotenuse, which is 13 squared. X is 5 squared plus y squared. And now we will be able to figure out what y is. So 25 plus y squared equals 169. You get 144 because you subtract 25 from both sides. 144 equals y squared. And now if you square root this, you get y equals 12. So that means y is 12 feet. So now we know what the height of the top of the ladder on the wall is, which is 12 feet. And I'll show you why figuring that out is important. And we also know that the distance from the wall to the bottom of the ladder is 5 feet. So now we're also given another piece of information, which says the bottom of the ladder slides away from the wall at a rate of 5 feet per second. So this is talking about dx dt. And it's talking, it's talking about dx dt because it says the bottom of the ladder, which is and we defined x as the distance from the wall to the bottom of the ladder. And it says it's sliding away from the wall at a rate of 5 feet per second. And that's basically how fast x is increasing. And this is going to be positive because since it's sliding away from the wall, that means the value of x is just going to keep getting bigger and bigger, and x is just going to keep increasing. So if x is increasing, that means the rate has to be positive. So now we just have to figure out what dy dt is. And we know dx dt is 5 feet. And we've figured out what y is. So to solve for dy dt, we need to manipulate the Pythagorean theorem formula. X squared plus y squared equals c squared. And in this case, c, which is our hypotenuse, that is the length of the ladder, right? And that stays constant because only y and x are going to change. Because y is going to change because if x slides away from the wall, that means it's going to look like this, then it's going to look like this, and then you see how this distance, y, that's just going to keep on decreasing. So y is also going to change, and so is x. But this stays constant at all times. This is always going to stay 13 feet. So now, let's take the derivative of this. So if we were to take the derivative of x squared, you would get 2x. And remember, since you're in, I said this in my previous video, since you're taking the derivative with respect to time, not the same variable. If we were taking it in respect to x, then it would just be 2x and you would call it a day. But you're taking it, the derivative, with respect to time. So it's going to be dx dt plus 2y. Same thing, but now it's dy dt because you're trying to find the change in y as time passes on, equals 2c times dc dt. And remember, the rate dc dt is 0 because the length of the ladder, or the hypotenuse, which is c, that is not changing at all. It's only x and y that are changing as time passes on. So this means dc dt, that is actually going to be 0. And 2c times 0 is going to be 0. So you're going to have 2x plus dx dt plus 2y times dy dt equal to 0. And now we can plug in our values for x, dx dt, and y, and we can solve for dy dt. So we know x is 5 feet. So 2 times 5 times 5, because dx dt is 5 feet per second, plus 2 times y, and we figured out that was 12. And that again shows why we needed to solve for y, right? Because if we solve for y, then we know what what y is, and that allows us to find dy dt. Times dy dt equals 0. 10 times 5 is 50. So it's going to be 50 plus 2 times 12 is 24. 24 dy dt, which equals 0. And since we're solving for dy dt, get dy dt by itself. So first subtract 50 to get it to the other side. You get 24 times dy dt equals negative 50. And if you divide by 24, you get negative 25 over 12. Oh, that actually simplifies even more. Let's just keep simplifying that. Negative 25. Oh, no, this is all it simplifies to. Negative 25 over 12 is what it simplifies to. So dy dt equals negative 25 over 12. And this actually makes sense because the rate is negative, and that makes sense because earlier, like I said, the ladder is going to eventually just start to look more like this. And that x is going to keep increasing. And y is just going to get smaller. And since y is decreasing, that means its rate, the change in y with respect to time, that's going to be negative. And our answer supports that. And let me add units. Negative 25 feet per second. And yeah, this is the ladder problem. And yeah, thank you for watching.